All right, this is problem 6.8 from Brigham and Houston, Fundamentals of Financial Management, Concise, 9th edition. It's expectations theory, and expectations theory says that whatever you earn on securities, they have no maturity risk premium. So if you were going to invest on a 4-year security and then reinvest the returns for a 2-year security, then your total return would be the same as if you lent the money for 6 years to a single individual. Okay, so we're comparing here. Interest rate on 4-year Treasury securities is 6.7, 6-year security 7.25%. Now, using Treasury securities because they have zero liquidity risk, zero default risk, and under expectations theory, there's no maturity risk. So the only other thing built into there would be the inflation, which would change the nominal rate. All right, so if we took a 6-year Treasury, then the total return that you would get on that would be 1 plus 0.0725 times 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 1 plus 0.0725. And that'd be your total return, 7.25% a year. So that would be the same as 1 plus 0.0725 y to the x6. All right, so you'd end up with the 1 as your original investment, plus you'd have interest equal to about 52.189%. So we could have done that with number of periods, rate, PV, FV, payment. If you lent for 6 years at 7.25%, if you put $1,000 and didn't add anything else, how much would you have? And the answer is 1521.89, which that's the same thing we're getting here. You'd have your original $1,000 plus $521.89 of interest. Okay, so all we're using now is mathematics because the guy doing chapter 6 likes the math better than he likes time value of money and using the computer to do it. Okay, now under pure expectations, if you did 4-year then a 2-year, still 6 years worth of investments, you'd get 1 plus 0.067 times 1 plus 0.067 times 1 plus 0.067 times 1 plus 0.067. That would be your return over 4 years. So if we were going to plug that into our time value money machine over here, over a 4-year period at 6.7%, you'd end up with 1,296.16. How much then would you have to earn? What rate would you have to earn over a 2-year period if you then started with your 1296 and ended up with 1521. All right, that way you'd be indifferent whether you lent for 4 years and then lent for 2 years, or whether you lent for 6 years at the beginning. Okay, so we're solving for this. That'd be the rate, number of periods, payment, present value, future value, and that would give us an answer of 8.3585% per year for that last 2 years. Well, I could do that here mathematically just by multiplying 1 plus x. That'd be the rate, the 2-year rate 4 years from now, times 1 plus x, and then set that whole mess equal to this. Okay. Well, I know the 1.067 y the x4 will be 1.29616. So I'd have to multiply that times 1 plus x squared and set that equal to 1.52189. Alright, so if I divide both sides of the equation by 1.296, that would tell me that 1 plus x, whatever that rate is, y to the raised to the second power, would have to be equal to 1.52189 divided by 1.29616. Okay, so that part is actually equal to that number divided by that number. So 1 plus x y the x squared has to be equal to this. Take the square root of both sides, that'd be 1 plus x would be equal to 1.17416, the square root of that. Subtract 1 from both sides, and then my x would be equal to 8.359%. I'm just going to show 4 decimal places. But that's the same answer I came up with over here. Alright, so I could do it either way. Do it using the math, do it using time value of money. The arithmetic's the same either way.